Question 18 offers us a rather awkward ratios question. We've got two ratios between A and C and B and C, and we've got to prove that this particular arrangement of A, B's and C's equals the ratio 17 to 20. Let's first of all take these ratios that they've given us and put them into the simplest form we can. Let's first of all look at equation 1. Let's turn these into fractions. I can say that 2A over 5C is equal to 6 over 25. That's the definition of ratios. We can turn them into a fraction. Well, if we divide both sides by 2 and multiply both sides by 5, we will create a huge simplification. So first of all, dividing both sides by 2, I get A over 5C is equal to 3 over 25. Now multiply both sides by 5, I get A over C is equal to, well, if I multiply this by 5, it cancels. This is simply 3 over 5. So therefore, A to C is equal to 3 to 5. Let's do the same thing for equation 2. And here we can divide both sides by 4. There's a common factor of 4. Divide by 4 and then multiply by 7. So the same process. Dividing by 4, I get B over 7C is equal to 5 over 21. Now multiplying by 7, I get B over C is equal to 5 over 3. So therefore B to C is equal to 5 to 3. Well, suddenly that's a lot easier. Now, if you notice, it is that C is common to both of our ratios. So we've got to get both of these ratios up to a common value of C, 5 and 3. Well, the best common value of that is 15. And we can do that by multiplying this ratio by 3 and this ratio by 5. So if I multiply this ratio by 3, I get that A to C is equal to 9 to 15. And similarly, if I multiply this ratio by 5, I get B to C is equal to 25 to 15. So A to B to C is equivalent to 9 to 25 to 15. But they want A plus B to B plus C. Well, A plus B is 9 plus 25, so that's 34 to B plus C, 25 and 15, which is 40. And that is equal to, because we can take a common factor of 2 out, 17 to 20. And that will be your answer.